Greetings, geometry students. We are about to embark upon chapter 3.5, equations of parallel and perpendicular lines. It wouldn't be, of course, a lesson if I didn't regale you with great humor first. And I've got two individuals helping me today. Thank you to Miss Holly DeVries and Felipe De Silva. Look at the Duh twins. You're the Duh twins. DeVries and De Silva. And I'm the teacher. Oh, there's a bonus I just came up with on my own. Nice. Anyway, you all may not know this about me, and this is true, but I'm an artist. I can draw just about anything. Portraits, still, landscapes, but don't ask me to draw horizons because that's where I draw the line. So, head shake. That was a winner. Yes. All right. So again, we're doing an abbreviated version of this chapter. Equations of parallel and perpendicular lines. I'm going to skip down. Holly, you're on the TV screen right now, yes? So we're in the four things we're going to learn. We're skipping the first one. We're not going to use partitions of directed line segments. We're going to identify parallel and perpendicular lines, write equations of parallel and perpendicular lines, and then the one that you all love the most, use slope to find the distance from a point to a line. Okay, those are what we're going to knock out in a relatively quick fashion. Supposedly I talk too slow, so I've got to go faster. Okay, here's your first theorem. Theorem 3.13, slopes of parallel lines. Nothing too dramatic about this. This is the easiest one of all. If you have a line that's in blue, and that line is red, and red is parallel to it, then the slope of the blue line is the same as the slope of the red line. In other words, parallel lines have equal slopes. I need you all to stop saying they have the same slope, because that doesn't help me put it into an equation. They have equal slopes, so you know to set them equal to each other. Please? Okay? Then the theorem just below it, 3.14, slopes of perpendicular lines in a coordinate plane. Okay, I'm not going to read it, but slopes of perpendicular lines. You've got the red line, and the blue line is perpendicular to it. You can clearly see that with the box that's drawn. So if the slope of the blue or the red line is a certain number, the blue slope perpendicular is the negative reciprocal. What you see here is when you multiply those two slopes together, it's -1. I don't need you to worry about that as much as knowing that the slope of a perpendicular line is the negative reciprocal of the slope of the line it is perpendicular with. All right, so we had this image drawn up there, okay, to work with. Identifying parallel and perpendicular lines, and you guys did this, right? I'm going to do it again, and Holly, what I'm going to ask is, because right now my computer screen is still broken, for those of you who remember me in the class, so I cannot draw on my screen. So what I would suggest you do if you're watching this is pull up this on Canvas so you can look at the page yourself, because Holly's going to move the camera over to the board where you can see what I'm drawing, right? All right, so we've got four lines, A, B, C, and D, and we want to find the slope for those four lines. So as we look back over here, remember we can do this one of two ways. The easy way is to count boxes. So I'm looking at the blue line. I have a point here and a point here. So the slope of the blue line, remember it's rise over run. It rises up 1 and it goes over 1, 2, 3. That means the slope of the blue line is 1/3. Line B is red. Same thing, rises up 1, but it only goes over 2. So that slope is 1/2. The green line, letter C, goes up 1 and over 2. Same slope, 1/2. And then the purple line is line D. Hopefully you understand when you look at these lines, any line going up from left to right is positive. Any line going down from left to right is going to be negative. So for this one, I look at this line and this line. It goes down 2, which is negative, and then over 1, which is positive. So it's -2 over 1, which is -2. Okay? So we've identified the slopes of those four lines. 1/3, 1/2, 1/2, and -2. What have we learned? Well, these two are the same. So what that means is line B and line C on that picture are parallel. -2 is the negative reciprocal of 1/2. How do I know that? Let me just put this up here so you have this little cheat to help you. Keep, change, flip. Keep the slope, 1/2. Change the sign, -1/2, and flip it. negative 2 over 1, which is the same as negative 2. So this slope of negative 2 is the negative reciprocal of both of these, which means line D back in that picture is perpendicular to both lines C and line B. Okay? Just also wanted to remind you, besides counting boxes, the other way you can calculate slope is with your slope formula. y1 minus y2 over x1 minus x2. So again, looking back at the blue line, the two dots are negative 3, 2, and 0, 3. Okay, so subtract the x, or subtract the y, sorry. Let's just go 2 minus 3, and negative 3 minus 0. 2 minus 3 is negative 1. Negative 3 minus 0 is negative 3. Negative 1 over negative 3 reduces to 1/3, which was the same thing we got when we counted boxes. No big deal. All right, so what I want to do, roll down to this section for you to work on it now. So Holly, please zoom in on that. Move it up just a smidge. All right. Don't do what I'm about to say, Holly. I'm going to tell them to do it. If you're doing this at home, pause so that you can calculate this for yourself. Okay, go ahead and pause now. Calculate the 4 slopes. All right. So the slope for line A, you go up 1, 2, 3, 4 over 2. 4 over 2, positive slope of 2. Line B, 1, 2, 3, 4 over 2. 4 over 2 again, that's also slope 2. So now you know A and B are parallel. Line C, here and here, I go 1, 2, 3, and over 1, that's a slope of 3. Not parallel to the others. Purple line, here and here. I go down 1, that's negative 1, over 1, 2, 3, that's negative 1/3. So the slope of negative 1/3 is the negative reciprocal of the slope of 3. So the green and the purple lines are perpendicular. The purple line does not have that same relationship with the blue and the red, only with the green, based on negative reciprocal slope. All right, next section, writing equations of parallel and perpendicular lines. What we're trying to do here is you've got, let me see if, it doesn't have that what I want, that's fine. What we got here is it's going to give you the line, whoops, and a point, and you're to determine the equation for the line that's parallel to the given line that has and passes through the given point. So I've written on this board, you guys all saw this week, the 7 steps. For this particular thing, it's only for the first 5 steps. Okay, we're only worried about the first 5 steps to solve. And the first step is very easy. You're just writing down the information you've been given. Write down the equation and the point. So in this one, the equation, y equals 2x minus 3, and the point is negative 1, 1. Step 1 completed. Step 2, identify the slope. Okay, so I look here, remember your form y equals mx plus b, m is the slope. My slope of this line is 2. Well, it wants us to find the parallel line, so we just said that parallel lines have the same slope. So my parallel slope is also going to be 2. So I've now done step 2 and step 3. Now I'm into step 4. Plug into the slope-intercept equation to solve for b. So my y, I find at this point, is 1. My slope, my m, is 2. My x is right there, negative 1 plus b. All I've done is plug in the values they gave us to solve for b. 1 equals 2 times negative 1 is negative 2 plus b. Add 2. My b equals 3. Step 4 complete. Last step, step 5, plug the slope and the b back into the original equation. Y equals 2x plus 3. So this is the equation for the line parallel to this line that passes through that point. If I made you graph it, you would see it, but I'm not going to make you graph it. Okay, next thing after that, very similar, just one slight different step. Now we're going to write the equation of a perpendicular line. Okay? Same 5 steps that we just did. One minor adjustment. All right. So, write the equation and the point. The equation. 2x plus y equals 2. And the point is 2, 3. Now, with this one, they gave it to us in standard form. It's an easy adjustment to put it in slope-intercept form. Subtract 2x to both sides. Rewrite it. Y equals negative 2x plus 2. All right. That's the first step completed. Second step is identify the slope. Negative 2. This one we're dealing with perpendicular. We said perpendicular slope is the negative reciprocal. Keep, change, flip. Keep negative 2, change the sign, and flip it. 1/2 is our slope. I've got the slope, I've got the point. Plug into this equation to solve for b. Here's y, 3 equals 1/2 times x, which is 2, plus b. 3 equals 1/2 times 2 is 1, plus b. Some of you continue to struggle with how to move the 1 over to this left side. Maciel, I'm thinking of you. All right, we subtract 1. Sorry, we subtract 1 from both sides. 2 equals b. Last step, step 5, plugging back into the slope-intercept equation. Y equals 1/2 x plus 2. So I now have the equation for the line perpendicular to this line that passes through point 2, 3. All right, and we're coming to that point where you now do your own work. I'm going to zoom in a little bit. We're only going to do number 4. You guys did this in class. Please do it again. Pause and get it done. Okay. So, parallel. Let me erase. I'm going to do this rather quickly. You say I go too slow, we're going to go fast. All right. Y equals 3x minus 5. The point is 1, 5, right? Yeah, 1, 5. Slope is 3. It's a parallel line, so it's the same slope of 3. Plug it in. Y equals m x plus b. B equals 2. My equation then is y equals slope 3x plus 2. And that's it. That's your parallel line. Okay? Next one wants perpendicular line. The equation, same thing. I don't know why I erased it. Same point. Why did I erase it? I don't know. It doesn't matter. All right. Slope is 3 still. Perpendicular slope is negative reciprocal, negative 1/3. Plug it in. 5 equals negative 1 times 1 plus b. Sorry, negative 1/3. 5 equals negative 1/3 plus b. Add 1/3 to both sides. B equals 5 and 1/3, which I like to rewrite as 16 over 3. So my equation is y equals negative 1/3 x plus 16 over. And last thing is the hardest thing. The algebraic thing. I'm anxious to see how you all do. Felipe, I'm anxious to see how you do on this.
I'm not even going to do that great on this.
Holly, you're going to kill it.
I don't like this.
Because your last quiz score.
Well, yeah, this one's fine. It's algebra, so I'm showing.
All right.
I'm
Anyway,
fine with it, but it's too many steps.
it's 7. We're adding 2 more steps.
Yeah, it's awesome though.
It just looks
Now your
wrong.
voices are on my video, so now the 100 sub special has to come from the 2 of you because I've made you famous now. See?
I'm down to be in the 100 special. Where's the mic on
You
this?
don't have a YouTube channel, do you?
I do have a YouTube channel. What?
Where's
I
the
have
mic
a
on this?
I don't know.
I swear if they heard me drinking my water, I'm deleting this
That would be
video.
amazing.
If they hear that, you're deleting this.
Am I?
Yes.
You should do it louder.
No.
Yes. All right. Lastly, find the distance from the point 1, 0 to the line y equals negative x plus 3. Again, reminding you, if I'm standing here and I want to walk back to that wall, which represents a line, the shortest distance to get there is a straight line perpendicular to it. That gets me to it fastest. So if I walk over that way, I will get there, but it will take me longer because it's furthest away. So the closest distance is perpendicular to where we're going. So when you find these distances, you're dealing with perpendicular slopes, okay? Same steps, we just add 2 more in. So start with where we started. Write the equation, and the point they gave us, 1, 0. And step through. Slope is negative 1. Perpendicular slope, keep change flip of negative 1 is just 1. Plug it back in. 0, the y equals m times x plus b. Okay? 0 equals 1 plus b. B equals negative 1. So I now can write my equation. Y equals 1 times x is x minus 1. So I have my 2 equations now. Okay? This is my perpendicular equation to this equation. So now I need to find the point where these 2 lines cross paths, because we need to take that point and this point and find the distance to get there. Okay? So now is where we do systems of equations. Let me rewrite this so it's a little higher on the board. So I have y equals x minus 1 and y equals negative x plus 3. Those are my 2 equations. So now we choose to do either substitution or elimination. I suggest elimination for this because it's already set up to eliminate. Draw your line and add. Y plus y is 2y. The x is eliminated. Negative 1 plus 3 is 2. Divide by 2, y equals 1. Alright, so I've got the y coordinate, now I need to know what the x coordinate is. Plug the 1 back into either equation to find what x is. So I'll go with this one. 1 equals x minus 1. Add the 1 to both sides and you find that x equals 2. So my other point now is 2, 1. I found my y of 1, my x of 2. So I have my 2 points. The last step is the lovely distance formula. Okay? Remember we did this. Write your template and fill in. Put x's here, put y's here. So 2 minus 1 and 1 minus 0. Okay? 2 minus 1 is 1 squared. 1 minus 0 is also 1 squared. 1 squared is 1. 1 squared is 1. Add them together. Square root of 2, which when you use your calculator is 1.3 if I remember right. Okay? And that's all there is to it. I know I said that. That's all there is to it, like it's nothing. I know it's steps. I know systems of equations is a pain, as is the distance formula. But you have the knowledge. You can watch this and get it accomplished. So you just need to get it done now. Let me just double check, make sure. I think that wraps up this lesson. It does. Wonderful. Thank you for watching. Like and subscribe.
Oh
Boom.
my gosh,
I have something to say first.
Oh, Lord.
This class is so boring without the other people in it. It's so boring.
Thank you for your
bro. Observation.
narrative,
I was gonna fall asleep.
and yet you did it.
You're a
Thank
cool
you for
teacher.
your help, Holly.
You're welcome.